All right, so we had a question about problem 9 from the week 3 assignment. So this can be a bit challenging to organize your thoughts. Um, I um, I know some students are trying to use two-way tables to organize their work, and that can be pretty difficult, especially when you're trying to understand um, the approach or what to do with their table after they build their table. Um, and I'll explain. The first part, what I'm about to go over, may actually explain how to use your table. But I'm going to show you a different approach that I prefer for these type of problems. It involves a probability tree. I'm not sure if any of you try to use probability trees. I know at least one student has reached out to me about using probability tree, but it's the way I prefer. Anyways, you don't have to. Two-way tables work too, assuming you organize it correctly. Okay, so first off, let's read the problem to understand why we want to use either process. If an individual was from Swaziland and has tested positive, what's the probability that he carries HIV? So I'm just reading the question at the end. So the question is, um, we're saying we know that they tested positive, or we want to only look at people that test positive. So what we're looking at is, okay, what is the probability that it carries HIV? So we want to know what is the probability of HIV, but we want to know only look at people that test positive. Okay, so that's the question. It's a conditional probability, and that's something you kind of have to be able to see based on reading the problem. This is a pretty typical question that they're asking here. Is what the probability of something, given that we know something else. That's pretty much what they're saying here, and this is what you get. HIV given positive. So what we're saying is we want to look at only people that test positive. That's all we want to look at, but we want to know the probability based on only the positive people, the probability that they have HIV. So the now we don't only want to look at HIV, because we know that they're testing positive. So we want to know the probability of HIV and positive, because we know that they're gonna be positive, because we know that they tested positive based on the problem. We're conditioning. We know that they're positive. What is the probability of HIV? So the numerator is HIV and positive, and we're dividing by the probability of positive, because that's everyone, because we know that they're positive. Okay, so that's what we're trying to find. Now, based on looking at this, um, so you could look at this and say, okay, well, um, the the ELISA test, ELISA, whatever, I don't know, I'm not really sure how to say it. ELISA, let's just say the ELISA test has different probabilities based on being uh, an accurate result if they have HIV, or accurate result that they do not have HIV. So it gets a little complicated there. That's why a two-way table or a probability tree. I'm going to give you, uh, I'm going to show you the probability tree. The two-way table is kind of the main process they kind of show in the class, so a lot of people are approaching that way. I'm not going to show that way. But uh, what we want to do is, well, realize is that the probability of getting positive, there's two ways of getting that. We could have a false positive, or um, a true positive. So it could be that they have HIV and they tested positive. So it could be that they have HIV and positive, or it could be that they have or they could have had, and that's a plus. We're adding this result with the probability that they have no HIV and they're negative. It's either one of those results, and that's the and they're positive. Those are the two different ways that we could get positive. Either they have HIV or they don't have HIV. But either way, they're going to be positive. That's the only way you can get positive result is through these two different ways. And our numerator is just HIV and positive because we want that. We want the HIV result. Okay, so that's what you could be finding. This is what you want to look at your two-way table if you built a correct two-way table. But if you're at all concerned, if you got the right result, I would suggest doing it this way and building a probability tree. So first you have HIV and no HIV. And based on the problem, we have 25.9% have HIV in Swaziland. So 0.259 and 0.741, just one minus. And then we can go from there and say, if they have HIV, we can either have positive or negative result. And no HIV, we could have a positive or a negative result. So they mention in the problem, for those who carry HIV, ELISA is 99.7% accurate. So that's 0.997, and this is 0.003. And from here, we can look at 0.926. And, oh, wait, sorry. Should have read that a little closer. 0.926 is accurate, but we tested negative, do not carry. So that would be negative. So that's 0.926 for this leg. And this is 0.074 for this leg. So, and then we can figure out the probability of HIV. So we can figure out the result of each leg. So there's 4 different results. And what you need to do, so this result tells us the probability of HIV and positive. And what you just do is just take the probability, and I'll just show you this one. HIV and positive. HIV and positive is just that result. And you just take the respective probability of each leg and take the product. 0.259 times 0.997. And that gives you the result for HIV and positive. Now, just to be accurate, I would suggest not rounding. Maybe just leave this product on the numerator, or just carry out all your decimals, because you want to be accurate to 4 decimals, and you can, if you round preliminary results, you're not going to be accurate to 4 decimals. So try not to round anything until your final answer. I mentioned this before, but just another reminder. And you can similarly do the same thing for each of these results. And you'll notice that we want to ignore all negative results. We only want to look at positive. So we can ignore this result and this result. And we're actually only looking at, so if I was to put here, ignore this result. And we only want to look at the probability that this is no HIV and positive. So, and you use these two probabilities to find its result by taking the product. And so you can figure out the rest of this result. Now, you may have realized that the result inside your two-way table, in the center of your two-way table, are going to be each of these 4 results. You should have these 4 probabilities in your table. You have HIV and positive for the intersection of having HIV and having a positive. And then you should have HIV and negative for the intersection of HIV and negative when you look at your two-way table. But anyways, I think this is easier to visualize and to look at the results, and this is what we're trying to find. So let me know if you have any concerns. This is what we're looking at. You just want to figure out the rest of this. I'll let you complete the rest, and let me know if you have any other concerns.